Right, 5.4.1. Let's get on with this. Right, so this is the section on depth of the center of fluid pressure. Right, we normally have shapes of a trapezium, which you can check in your textbook. Then there's a parabola, and then here we have a triangle. We could have a rectangle. The main thing is you get your sketch 100%, the rest will be easy. Alright, so a triangular plate of sides 5, and 6 meters is placed vertically in a canal which is 5 meters deep. The longest side of the plate is horizontal and is 1 meter below the water level. Okay. Make a neat sketch and calculate the relation between the variables x and y for 3 months. Okay. So, for this type of question, you sketch your xy axis. Right, there's different methods, there's two methods here. One is where the bottom, the x-axis is the water surface. Right. And the other method is where the x-axis is the ground. Right, so now here a triangular plate. So let's draw that triangle. This is how you're going to do it. Here is your triangle. Right, so now it's placed vertically. So there's it inside. Now you are in a canal which is 5 meters deep. Yeah. So it is 5 meters deep. The longest side of the plate is horizontal and is 1 meter below the water level. Okay. So here is the water level. Okay. Now what we need to do in this situation is know what these values are so we can find an equation. There is no equation here at the moment. Can you see that? There is no equation. We're just given dimensions here. So what are the dimensions? You are told, let's do a rough sketch here. So the longest side, so you know from here to here is 6 meters. Okay. Because remember, the longest side of the plate is horizontal and is 1 meter below. So this is the longest side. That's what they say. So this side is 1 meter below the water surface. Alright. So this is 6 meters and you are told that this here is 5 meters and here is also 5 meters. You clear with that? Right, so there we got 6, 5 and 5. So we know the distance from here to here is 6. What we're going to do for these type of questions is the y-axis will cut this into 2 equal halves. Right. So use the y-axis, whatever diagram you have, whether it's a trapezium, whether it's a parabola, whether it's a rectangle, the y-axis must cut it. So what we can do is we can have a distance, the distance from here to here and from there to there will be equal. So we know that the distance from here to here is 6. So that means this will be 3 and this will be -3 on the negative side. But the distance from here to here is 3 and the distance from there to there is still 3. Okay. Now, the distance from here to here is 5 meters. You're clear with that? So, what is the height from there to there? Okay, so let's do this here. So here is your triangle. Right. And if I draw a perpendicular line here, what happens? You have a right angle triangle. Okay, so now you have a right angle triangle here, and you know that the distance from here to here is 3, the distance from there to there is 5. So if I want the remaining side, I will use the theorem of Pythagoras. Right, so from Pythagoras, okay, let's label them properly now. Let's call this here A, let's call this B, let's call this C. Right, so let's call this part here G. Right, so now from here that's this was D, this is B, this is C. So from Pythagoras, we know that the square of the hypotenuse BC squared is equal to the sum of the squares of the other two sides, which is DB squared plus BC squared. So BC is 5, so that's 5 squared. DB is, where is my DB? That is 3 squared. And then DC. Why did I write down DC? There is DB, DC. DC is what we are looking for. Right, so we got 25 minus 9 is equal to DC squared. So 16 is equal to DC squared. So therefore, DC is equal to the square root of 16, which is 4. We're clear with that? Alright, so that means the distance from here to here is 4. So this is 0, 4. That means the y value here is 4. The y value here is 4. And what did they say? It is 1 meter. Where is that? 1 meter below the water level. It makes sense now. Because how deep is the canal? It's 5 meters. That means from here to here is 5. So that is 0.5. You didn't have to go and use the theorem of Pythagoras. You did not have to do that. But it's good to make sure and check. Right, because if this is 5, 5 minus 1 is 4. You can always subtract. Right, but remember, theorem of Pythagoras. Right, so now, what we need is to form a relationship between x and y. So for this type of example, we will always be using this type of representative rectangle with a breadth of delta y. It works much easier when you deal with it this way. Okay, so you always use a representative rectangle of delta y. Now, if I want to work out the area of the representative rectangle, so I'm going delta A area is equal to length times breadth. Okay, so what is the length of this rectangle? So now remember, from area, we know that the distance from here to here is an x value. Okay, the distance from here to here is also an x value. But if from here to here is 3, okay, let's take an example. From here to here is 1. From here to here is also 1. So what will the distance, total distance be? 2. If from here to here is 5, and if I want the total distance, it will be 2 times 5. Understand that? So, the length from here to here is x, but if I want the total length, it's going to be 2x. Okay, that's going to be 2x times your breadth, which is delta y. Now, the formula, okay, now, we need Since this is delta y, we need to integrate with respect to y, which is the next question, but we need to show the relationship between x and y. So we need x in terms of y. But we don't have an equation, so we need to form an equation now. So all you do is, look, you can take this straight line here, or this straight line here, but not the top straight line. Okay, you can take these 2 points here and work out the equation of that line. So let's take these 2 points. We got C and B, which is 3, 4. So if I want to work out the equation of this line, I need to work out first the gradients. So I'm going to go M of BC is equal to YB minus YC XB minus XC. The change in Y over the change in X, which you can do by inspection too, but let's just do it the proper way. So this will be 4 minus 0 all over 3 minus 0, which is equal to 4 over 3. Now, what is the equation of a straight line? So that is my gradient. The equation is y minus y1 is equal to m into x minus x1 for any straight line. So we can use any point here. Okay, although this can be done by inspection, but you can use any point that lies on the line. Right, so we got y minus, let's take y minus 4 is equal to m, which is 4 over 3, and then you got x minus x1 there, which is 3. So now, let's make y the subject of the formula. In fact, we need to make x the subject of the formula. Okay, so what will happen here? So if I got y minus 4 is equal to 4 over 3x, and then 4 over 3 times minus 3 will be minus 4. Okay, so therefore y is going to be equal to 4 over 3x, because if you got minus 4 on both sides. If I take minus 4 to the left, it becomes minus 4 plus 4. So y is equal to 4 over 3x. We could have just used 0, 0, which is easier. Understand that? I'm just showing you that you can use any points. So now, what are we dealing with now? Right. We got 2x times delta y. We need an equation. We have an equation. We want x in terms of y. So I make x the subject of the formula. So if I cross multiply there, it's going to be 3y over 4 is equal to x. Right, so if I take this, and I can put it here. So that's going to be 2 times 3 over 4 y delta y. You follow what happened there? All I'm doing is substituting. So 2 over 4 is the same as 1 over 2. So that's 3 over 2 y dy. So we have our relationship between x and y. Now, the next question. The next question, I'm not going to write down the whole thing, but basically it is calculate the depth of the center of fluid pressure. Okay, 5.4.2. Alright, we're going to work that out now. Alright, so 5.4.2, basically it's calculate the depth of the center of fluid pressure. Let me just read out the question. Calculate the second moment of area of the plate above the water level, as well as the center of fluid pressure. If the area moment, okay, is equal to 28 meters, so let me write the given information here. You are told the area moment is 28 meter cubed. Okay, this is a 5-mark question. So what is this 28 meter cubed? Now, the depth of the center of fluid pressure is given by the formula. You got D and C, R squared. dA means the area delta A, all divided by D and C, R dA. Okay. So what is R? R is the distance from the water surface to the representative rectangle, which now I realize that I forgot to put down there. Sorry about that. The distance from the water surface to the representative rectangle. Right, so your R, the distance from there to there. So how do you work that out? It's always going to be the water surface minus whatever you have here. The distance from here to here. So if this is 4, 5 minus 4 is 1. If this is 2, 5 minus 2 is 3. But we don't know what it is. It's a y value. So it's always going to be 5 minus the y value. Okay. So this is the R that we're going to be substituting here. dA, well, there's dA here. Same thing. Delta A is dA. Now, we were given the area moment. Now, which is the area moment? This is the first moment of area or area moment. And where you see the R squared, that is the second moment of area. Okay, so we don't have to work out the denominator because we're already given the answer here. Can you see that? Alright, so we will work out the second moment now. So let's take this and write it down. So the second moment of area so we got our D, C, R squared dA. So what are we dealing? We are dealing with a triangular plate. Okay, and where does the plate start? From 4 down to 0. Okay, from 4 to 0. So we're going to go 4, and this is 0. And what is R? R is equal to 5 minus y all squared. What is dA? dA is 3 over 2y times dy. Okay, delta y, dy. We're integrating with respect to y. Alright. So now this is going to be 4, 0. We're going to simplify this here. So that my 3 over 2. And 5 squared is 25 minus 5y, that's minus 10y plus y squared times y dy. So now the integration part is easy. All you have to do is remove the brackets there. So therefore, we got 4 and 0. 25 times y is 25y minus 10y squared plus y to the power 3. Right, so now it's just basic integration. You don't even need the formula sheet for this one. That's going to be 25y squared over 2 minus 10y to the power 3 over 3 plus y to the power 4 over 4, substituting 4 and 0. Give me the calculator. Give me that calculator, that one. That's it. double check me here. So that's when we are substituting 4, we get 152 over 3. Substitute 0, you're getting 0. What is 150? Okay, 152 over 3 times 3 over 2, 76. This is meters to the power 4 because area is squared, r is also squared. A square times a square will give you the units to the power 4, in this case meters to the power 4. Alright, you must go over the worked examples in your textbook similar to this. It just takes long to do, but 5 marks here, and that's 8 marks. Easy 8 marks here. So what do we have? This is not the final answer. We need to now substitute. So therefore that is 76 meters to the power 4 divided by 28. Right, so that's divided by 28 and we get 19 over 7, which is equal to 2,714 meters. Why does this feel like the one straight from the textbook? I'm not sure, but anyway, I remember these values here. Right, so this was the question on fluid pressure. Right, so question 6 is determine the length of the curve. Y is equal to 9 minus x squared. From x is equal to 0 to x is equal to 3, which is 6 marks. So basically you are differentiating first, integrating second. Right, so this is the formula straight from the formula sheet. So you go to your formula sheet. Where will you find the arc length formula? It is on page 7 of the formula sheets. So the last page, on page 7, you will find all the arc length, and page 6 is for surface area. Okay, so let's see, this one. Yeah, there's it. This one is the first one under arc length. Alright, so what do we need to do? Let's do it fast. So what do we know? Y is equal to 9 minus x squared. We need to find dy over dx. So dy over dx, the derivative is minus 2x. What else must we do? We need to put it in and square it. So if I go, we're integrating from 0 to 3, and this is dy over dx squared, so that's minus 2x squared. Right, so that's going to be 1 plus 4x squared. Now you go to your formula sheet, because this is integration by completing the square. Okay, integration by completing the square, you need to choose the correct formula here. Alright, so which one are you looking for? Let me write it down. So this is the one. The square root of x squared plus or minus b squared, because there's a plus here, there's a square root, there's no fraction here, you can see that. So you make sure that you identify the correct formula. So this is going to be x over 2 times the square root of x squared plus or minus b squared plus or minus b squared over 2, then absolute value of x plus the square root of x squared plus or minus b squared plus c. It's the second last one under on page 4 there, under integration by completing the square. Now let's make sure everything is correct here. X squared plus or minus, plus minus there, plus minus there. Right, so now let's work with it. So notice the coefficient of x squared here is 4. The coefficient of x squared in your standard form, the formula is 1. So what do you do? What do you do in a situation like that? You could use a U substitution, or you could take out 4 as a common factor. Okay, it's up to you what you want to do here. Right, I think it will be faster. It depends, but you try it out both ways. Let's take out a common factor. So, what's going to happen here? Watch. I got 1 plus 4x squared. Right, I'm going to deal with the square root now. So, if I take out a common factor of 4, that means term 1 will be 1 over 4, term 2 will be x squared. Check, 4 times 1 over 4 must give you 1. 4 times x squared is 4x squared. You know, see that? Now, if I put a square root over it, so now I have the square root of 4 times the square root of 1 over 4 plus x squared. Because it's multiplication. Now, can you see that? Now, let's do it here. So this is, we have 3, 0. And then I have 1 plus 4x squared. So what did I do? I took out 4 as a common factor. The square root of 4 is 2. And now what do I have? 1 over 4. Well, let's write it as x squared. So that's x squared plus 1 over 2 all squared dx. There's the 1 over 4 here. There's the 1 over 4 there. Can you all see that? Right, so now it's all about just substituting and using your calculator. So that's going to be 2. So what do we do? X over 2. So that's x over 2 times the square root of x squared plus b squared, which is 1 over 4, same thing, plus b squared over 2. Well, let me just write it as it is there, so you won't get confused. This is b squared, and then I got b squared again over 2, ln absolute value x plus the square root of x squared plus 1 over 2 squared, and we're done. So let's just go straight and use the calculator. So what do we have here? 3 and 0. Okay, you don't have to go and simplify, you're wasting your time. Okay, the main thing is you apply the formula, it's a correct standard form, and now go straight to your calculator and let's substitute these values. That's x over 2 times the square root of x squared plus 1 over 4 there, plus, then we got 1 over 4 divided by 2 there, and then x plus the square root of x squared plus 1 over 4. So what are we substituting? 3. So when I substitute 3, I'm getting 4, 7, 8, 6, 9, 0, 0, 9, 8, 2, minus, when I substitute 0, you don't get 0, you get minus 0, 0, 8, 6, 6, 4, 3, 3, 9, 7, 5, 7. So if we work this out, that's plus 0.0866, 4, 3, 3, 9, 7, 5, 7. So this is 4.8735, 4379 times 2, which is going to equal to 9,747,088,759. which is just equal to 9,747 units. So if you know which formula to choose properly, that's easy. This was an easy 6 marks compared to anything else. I mean, compared to the volume, second moment of area, moment of inertia, centroids. The main thing is you must know how to simplify it. Okay. I took out 4 as a common factor. So that was arc length. Let's deal with the last question. Now we come to the end of this exam with a surface area question. Calculate the surface area generated when the curve x is equal to y cubed from the point 0, the y value 0 to 1 is rotated about the y-axis. So you will go to page 7 of the formula sheet. You should be familiar on which one to choose. If it says AY, means about the y-axis. If it says AX, x-axis. Right, so what do we need to do? We need to work out dx dy. We need to square it. Let's see what happens. So what do we know? That x is equal to y cubed. So dx dy will be 3y squared. You're clear with that? So if I squared dx over dy all squared, that's going to be 3y squared all squared, which is going to be 9y to the power 4. Now, let's do the substitution. So what's your D and C? It's given to you. 1, 0. We got 2 pi. 2 pi is a constant. X, what is x? X is equal to y cubed. And then we got 1 plus dx over dy all squared. That's 9y to the power 4. Well, this is an easy one. So this paper started off difficult, but it ended up okay. Because from here now, you should recognize that this is exact derivatives. Can you see it? If this is y to the power 4, y to the power 3, that means exact derivative. If you want to, you can let u equal to 1 plus 9y to the power 4. This is u substitution. So then du dy, the derivative here 9 times 4, that will be 36y cubed. Make dy the subject of the formula, which is going to equal to du divided by 36y cubed. Okay, the main thing is you recognize that it is type A. This is your N5 work. So what do we have there? 3, 0. We got y cubed. We got u. And then we got du divided by 36y cubed. Sorry? Oh, sorry. No. That's 1 and 0. 1 and 0. So y cubed and y cubed will cancel. So you end up with 2 pi over 36, 1, 0, and then you got u to the power half du. Too much of work with this substitution method. Can you see that? So 2 over 36 is the same as 1 over 18 pi. Integrate this. Half plus 1 is 3 over 2 divided by 3 over 2. That's 1 and 0. Don't forget to sub. We are not changing the limits here, so we will substitute back 2 over 3. That's u to the power 3 over 2. What was u? U was 1 plus 9 y to the power 4. So we are substituting for y, not for u. Be careful with that. Let's see what we get. Two over 3 over 1 plus 9. Yeah. So we get, when we substitute 1, I'm going to get 21, 0. 8185107 minus, now let's substitute 0 and we get 2 over 3. So it's there, minus 2 over 3. So this is 20, comma 4151844 4 times pi over 18, which is equal to 3, comma 563121852, rounded off to 3 decimal places, 3, comma 563 units squared. So let's make sure that this answer is correct. So let's use the integration function on the calculator. So we got x to the y to the power 3, 1 plus 9, 4. That's 2 pi there. Let's do this and check what happens. So I'm using the integration function on the calculator, and my answer is perfect. 3,563121582. This answer is correct. Right, so that will be all. This is the revision for tomorrow's paper.